Today we are exploring an agent-based model designed to test hypotheses surrounding megaherbivore extinctions. So this model simulates large-bodied ungulate population dynamics within a dynamic grassland environment, incorporating factors such as environmental change, human hunting strategies, and prey profitability. So before we begin, could you please introduce yourself?
Sure. My name is Isaac Ula. I'm an associate professor of anthropology at San Diego State University, and I direct the computational archaeology laboratory here.
Could you explain the main objectives of this model? How does the model contribute to our understanding of megaherbivore population dynamics and the potential role of human hunting in past extinctions?
Absolutely. So, this model is meant to be an exploratory laboratory to understand the interaction between human hunting pressure, climate change, and environmental dynamics on the population dynamics of large-bodied herbivores. And we particularly developed it to explore the idea of the role of humans in the extinction of what are called the megafauna. These are very large-bodied herbivorous animals all around the world. We created the model in such a way that we could tune the life history parameters of the herbivores in the model, their herd dynamics, their reproduction, and all of that kind of stuff. And we could tune that to a specific lifespan and life expectancy and fecundity and all of those things. We can tune the human hunting preferences, and we can then tune the environment and the climate as well. In terms of human hunting, we wanted to, again, lean a little bit on optimality modeling, but make it more realistic. Again, introducing the ability for some error and some bias, but also allowing hunters to make more specific decisions about these prey. Particularly, we're thinking about male and female animals and female animals that are pregnant or have a calf. And we're looking at the different payoffs and the different costs. We ran some experiments. We also changed the environment to look at how climate change at the end of the ice age may have affected the life history of these animals. We made the environment more patchy. We made it more seasonal. We made it so that the resources could replenish, like the grass and stuff could grow back faster or slower. And we modeled a series of experiments to see how these different components would play out. And we found some really interesting boundary conditions where uh, human hunting preferences, in some cases, yes, you can force them to overkill a population, but in other cases, it depends on what the environment is doing and the feedbacks between them. And it's not 100% guaranteed that that situation will lead to an extinction event or not. And so that middle ground for us is the really interesting area, because when we looked at those scenarios, they seem to be the most realistic, the ones that would match maybe more what was really going on at these different times and places with these different populations of hunters, different populations of mega herbivores, and different environmental dynamics.
What were some of the biggest challenges in developing this model? How did you balance, ecological realism with the need for a simplified yet dynamic simulation?
Yeah, I mean that was definitely a big challenge, and one that we certainly got pushback on from reviewers and from editors when we published this. But we decided to go with a more simplified environment, not trying to replicate any one particular place, because we wanted to retain the flexibility in the model. We wanted to be translatable between places. And so, in conversations with the reviewers and editors, and then with some revisions to the paper that we wrote, we explained this is not a toy model. This is more realistic than four parameters that you can pull bars on and kind of get a real gestalt understanding of something. But this is not a hyper-tuned specific model to one time and place.
Hmm.
Instead, we made it flexible enough so that you can model a range of environmental dynamics that are plausible in grassland, woodland mixed areas, a range of life history parameters so that you can include different types of mega herbivores and a range of human hunting pressures. And we showcase this with a particular case, archaeological case study in South Africa. So I think that was really an important thing to explain that the case study was not the point of the model. The case study was used to inspire some experiments in this more general model so that we could then go back to the archaeological record of that case study and get some insights about how the model performed, how the model uh, informed our understanding of that case study, but also how the findings could be made more general, right?
Let's talk about the results.
Yeah.
Have you observed any notable trends or unexpected insights from model simulations? How do factors like hunting preferences or environmental fluctuations impact megafaunal populations over time?
What we noticed is that human hunting that went after females, and particularly females, again, they can be pregnant with calves, could interrupt breeding cycles in this large bodied, long lived, sexually dimorphic herbivore and put it closer to at risk, right, for extinction by interrupting the ability to replenish the population. It's not 100% guaranteed, however. There has to be some accompanying changes in the environment. In a very lush, fast growing, fast replenishing environment, humans can do this hunting strategy, and the population would be kept maybe lower than it would be without the hunting,
Hmm.
but it wouldn't diminish to the point where it was at high risk for extinction. However, when we simulated fragmentation of the environment and changes to the seasonality and the replenishment of the grazing materials that this animal would have access to, that is when this particular disturbance could really start to push towards, obviously towards extinction, which is what we were looking at. And there were some scenarios that always led to extinction. Really high pressure of hunting pretty much always leads to extinction. Uh, Really, really bad environments kind of always led towards extinction. For us, the really interesting thing was finding the boundary conditions between those two extremes where extinction was not a guarantee. And again, for us, one of the interesting things is to change the narrative, which is to say humans could have done it, but didn't. It wasn't necessarily just them alone, and it wasn't a guarantee. The human hunters wouldn't have had an opportunity to know that, oh, we're doing this, we're causing this. They're just doing what they always did, and a small shift in the environment all of a sudden changes the dynamics, and the chance of extinction goes up, right? And it could happen in this place and not in that place. And in particular, this animal, Centrus antiquus, went locally extinct in South Africa, but seems not to have gone locally extinct in northern Africa. There's rock art from a few thousand years after its extinction in southern Africa, in what is today the Sahara, but was at the time a big grassland, right? And it was still living up there. So, same animal, hunter gatherers still focusing on hunting these kinds of animals, and two different places, two different results.
Hmm. You made the model available using ComSys.net. Were there any challenges in making this model accessible, especially, in terms of its documentation and its usability and reusability?
Yeah. Firstly, I love ComSys.net. It's a really great resource, and it's really helpful to have a trusted resource to put these models. And this was the first model that I really pushed through the peer review process at ComSys. And so for me, the challenges were not fully understanding how to create the right documentation and to do the code styling correctly. um, I have some experience in NetLogo before this, but this was the biggest NetLogo model that I had written to that date. And it was really helpful in the peer review process to get some feedback on the code and the comments and how I should define the functions. And so I did have to go through a couple iterations of code refinement in the peer review process. And I had to create the ODD document, which now I know, I should have known, is the right way to do it from the beginning. And all the projects I've done since this time, obviously, I'm doing the documentation that way. Um, so the challenge was sort of navigating that at first, but it was actually quite rewarding. And now that I know it, subsequent peer reviews have gone a lot smoother with COMSIS. And also, it's helpful when publishing the results in a journal article, because now not only do we have the ODD document and the peer review stamp, but I can then create the summary ODD to put the model description into the paper, put the DOI, and that is very helpful for journal editors and for reviewers of this stuff because they can go, they can find it, they know that it has also been looked at, they can trust the code more, and chances are a lot greater that they will be able to download it and run it and verify results.
So, are there plans to refine or expand the model or test new extinction scenarios or consider its applications to other ecological or archaeological questions?
Absolutely. In fact, we are in the middle of new experiments porting the same model to actually looking at historic ranching in southern Arizona.
Hmm.
This is kind of an interesting, uh, I would say, a fork of the model because we have to make some code changes to make this work. Working with my colleague, Dr. Nicole Mathwick, who's also a professor here at San Diego State, who's been working in this area, and she has some really interesting records from some of the missions in southern Arizona. Numbers of cattle, numbers of goats and sheep, and numbers of horses. And it's a really interesting place because these are new species being introduced when Spanish missionaries came into the area, but native populations are doing a lot of the actual ranching work. They have their own understanding of their landscape and their own histories of agricultural practice. And we have other native groups who are coming in to do raiding, and there's warfare happening in the region as well. So,
Thank you very much for joining me.
thank you very much. Happy to talk.